Oh wait, so we don't be.
Alright.
We don't be in the. You know?
I want to
Yo,
No,
it's
it's
with
the
your face
board
now.
so that you can see. Actually, and I think you also did give me permission, and your parents gave me permission for my national board stuff. But all that being
I told
said,
her not to. Man, I was gonna watch the video because I thought it was a camera. I'm not watching no more.
okay, it's a good threat.
It wasn't a threat. I was talking to myself. Mad now.
That's not how you do it.
Let's see. Really quickly, can someone tell me if they created the table on the calculator?
I did.
Maven, you did? Kathy,
Hey.
you did?
You not.
Raise your hand again.
Alright,
Cut it off.
so Maven, tools, live presenter. Okay. So, here we have Maven's calculator, where she has days, and she has option 1 and option 2, and it doesn't quite
That's
look
wrong.
like you knew what to type in, do you? Hold on. Hold on. Chill.
I did not.
Stop. I need you all to focus up here. So, option 2, that you don't know, you don't have an equation to type in there? Not sure about it?
She don't know.
It's okay. That's fine. Alright, hey. I need everyone to stop talking and listen. Okay, so here we have a table created with some of those data values. At this point, which one are you going to go with?
Option 1.
Option 1 for sure.
For sure.
Has anybody decided based on what they've done to go with option 2, or are we all on option 1?
I'm sure.
If you want 0.0,
Okay? So, here's the thing though. Hold on, y'all. Cancel.
she's gonna be cleaning stuff.
There you go. So here's the thing though. We're only looking through day what here?
4.
Here's day 4, but we're supposed to look through day what? 30.
Daddy.
If you look at the short term, you're going to miss out on some important information, okay? We need to pay attention to what's going on here. Did anybody come up with an equation to type in there? Sorry, let me clarify. Did they come up with an equation and actually type it in here?
Well,
I
we're
didn't know.
I mean, you can. So let's watch this. Braden, did y'all get an equation in there?
I got the equation.
I know this group did, if y'all did not.
Can I like insert it right now?
I mean, you can.
I got a question.
Yeah, we did.
Y'all did?
I got a question.
We good. I was
Okay.
okay.
So I'm going to make Braden live presenter for a second.
Wait, Mr. Kenny, I didn't get an equation for the second one. Just
That's okay.
Alright.
So I want you to notice. Oh, I don't want it like that. That's fine. That is not what I wanted though. All right, Robert, we're going with you because I know you have it in there. What you did is perfectly fine, Braden. That's just not what I wanted. Okay, so here we go. We have actually 2 equations for Robert and his group. I want you to notice option 1. He made the statement 60,000 times days. When you type this equation in, Robert, and the rest of your group, did you have to type each of these numbers in?
Nope.
Nope. You just had to do the days, and then once you typed the equation in, it gave you everything, right?
Yeah.
This is why equations are useful, because it can make your job much easier, okay? And so when we look at that table, I'm going to separately make it over here really quickly. We get our days, we get our money for option 1, and day 0, we got $0, 1, 60,000, 2 is 120,000, 3 is 180,000, 4 is 240,000. Now, that keeps going. And I want to say this. Even if you did not know what that equation is, Bree, I need you saying away. Come
Oh,
on.
actually.
No, I'm not sure. Even if you did not know what that equation is, you could figure out that equation once you created the data. Okay? So, Robert, can you go to, I believe you already graphed this data, correct? Go to a graph page. Hey, really quickly, what does that data look like?
A straight line.
That looks as straight of a line as it can be. Now, just to clarify, all lines are straight, okay? But it's a line, it is a linear function. Very clear, correct? Yes? Okay, so, does anyone know of a way that we, say again?
How many days can we do?
It looks like that's going, here, click on, hover over this point really quickly, Robert. Day 30.
Day 30.
We gotta do that.
I mean, how long was the contract for?
30
days.
days.
I'm gonna do 7.
I mean, I hear you. So here's the thing though, what I'm about to show you could have helped you get all the way through the end. So, does anyone know how we could figure out the equation of this linear data?
Of course.
So,
Get a trend line?
The
Hey,
trend
can you hit
line.
menu and go through creating the trend line for us real quick? So if you should already hopefully have a table at some point created. Go through the process. Okay, so regression. What type of regression?
Show linear
Show
and
linear.
x plus b.
Hey, look at that equation.
Look at that nice equation.
Y equals 60,000 times x plus 0. Okay?
Now you get it.
So a couple of things I want to talk about and bring up here. First off, we can very clearly see this is what type of function? This is a linear function. Why is it linear? I need y'all to listen to what Caroline just said because she had me last year. She heard me say this a lot, and this is fundamental. Go ahead and turn your page over to where it says whole class discussion notes so that you can write this down. So Caroline, say that one more time for us.
Repeatedly adding.
What is it repeatedly adding by?
60.
60,000
50,000.
plus 60,000 plus 60,000 plus 60,000. That
Oh my goodness.
is what is making this be a linear function, okay? First off, I do want to point this out, it's additive, yes, but what is the term we would use to indicate that it keeps happening over and over and over again? It's a constant additive rate of change. The constant additive rate of change, I'm going to go ahead and show you the abbreviation I usually use for that, ROC. The constant additive rate of change defines this linear function. And it defines all linear functions. There will be a constant additive rate of change if it's linear. Okay? Secondly, what is the name of the constant additive rate of change? Think about a line. What is this rate of change called?
Rise over and lower.
That's how we calculate it. What's it called?
Slow.
The constant additive rate of change is the slope of the line. In the table, it is called a common difference. Usually I wouldn't sweat that detail, but that is one of the big ideas on the sheet that I've given you. It is called a common difference. It is the difference between these two numbers, right? The difference between 60,000 and 0 is 60,000. The difference between 120,000 and 60,000 is 60,000. It is a common or constant difference.
So like if the rate of change, if it's not the same, then yes it is.
If it's not a constant additive rate of change, it will be something else. That's a great question, that's a great detail. If it's not a constant additive rate of change, it will be something else. So, what is my slope in this case?
6,000.
60,000
Oh,
divided by 1. But, and that is true, and we can talk more about that, but the bigger thing I want you to focus on right now, that slope is 60,000, and it's being multiplied by x. Why?
so the
They go up 60,000.
Okay, but why is it adding? Or why is it multiplying? And Caroline just said it again.
Repeatedly adding.
It's being repeatedly added. Remember, and this is why I brought this up in the first unit, every time you see that multiplication, it means you have repeated addition, okay? So, n equals 60,000 is multiplied by x because there's repeated addition. That is important to notice, because that slope is always going to be multiplied by x because it is what you are repeatedly adding by. And we know that it's calculated using slope, or rise divided by run, right? But that's why it's being multiplied by x. We need to understand that. Okay? There's only one more detail that I want to pick up right here. Yes. Where is this 0 coming from?
The y-intercept.
Say it louder.
The y-intercept.
That's the y-intercept. There are multiple versions of every equation that you can study. However, the best starting point, no matter what you're dealing with, is the y-intercept. If you can find the y-intercept, it is much easier to write the equation. So I would personally make a note to myself, no matter the type of function, or regardless of, I guess I really should say linear exponential. So yeah, what I'm telling you only matters for linear exponential. But regardless, if linear or exponential, the y-intercept is a great starting point. That is probably what you want.
Oh, snap.
Because if you can find that y-intercept, then you are pretty golden, because you already have your slope and the y-intercept there, right? Y equals mx plus b. You need that slope to multiply by your x. You need your y-intercept, because that's where you're starting. Jordan, come on. You need to take notes. Yeah, come on. This is foundational to everything else we're going to study. This is pretty much everything that you need to know about a linear function. What makes a linear function linear?
Oh, repeated.
Repeated addition, not just additive rate of change, a
Constant.
constant additive rate of change. And Kanye, what do we call a constant additive rate of change? It's what?
A slope.
A slope.
So you got
Remember,
me
that
right.
constant additive rate of change is called a slope. There's another word for it, the way it shows up in the table, it's called a common difference. Okay? So a common difference is that constant additive rate of change, okay? Now, I do want you to take a note. Hey, listen. Hey, listen. I want you to take a note here about different representations, right? So we're going to go into exponential in just a second, but I want you to notice that if you have a table or a tabular representation, what can you easily see in the table? What were you able to easily identify?
The rate of change.
The rate of change. Tables are great for identifying the rate of change. You can make this on the front if you drew a table there, or just anywhere you want. But tables are great for identifying the rate of change.
Tables are good.
What is a graph good for?
Graph is good for the.
Graph your data, put your data.
Okay, so you can graph it, but then you can see the what?
The slope.
Is it always going to be a line though?
No.
So you're not always going to have a slope, but we would call that the shape. Okay? Graphs are great. No, that's not a function. It's a shape, but when I say a function, or when I say shape for functions, I mean stuff like this.
Oh. We got a question over here.
Okay, just hold on a second. That's what I mean by shape.
It just goes Jaden by triangles. Why do y'all tell us to prove it's a triangle when you can look at it?
I don't think anyone has ever asked you to prove that's a triangle. Maybe prove that it's a right triangle.
Yeah.
Yeah, like why when you can look at it and see it?
But what if it's a left
I'm
triangle?
not. So a graph is great for seeing
Yeah, cutie.
the shape of the function. And the shape, hey, The shape of the function tells you a lot about the function right away. If it's creating a line, it's what type of function?
A linear.
A linear, right? So tables are great for identifying the rates of change. Graphs are great for seeing the shape. And so together they can give you great information. So why do we want an equation? Because can't you plug anything in for x once you get the equation?
Yes.
Right? Did Robert have to actually do any of the points for option 1? No, he just put that equation in. If you know the equation for option 2, you don't have to actually put any of that in. And I saw Braden doing this earlier where he just typed an equation into a graphs page and looked at the graph. We all good with that information? Okay? So make sure you have that information before we start moving into the next type of function. So,
Say good job, Tim.
You're doing a lot, though, right?
Good job, buddy.
I already voted.
I said we're doing a lot of note writing.
okay? I want you to notice when I am starting this table for option 2, where am I starting it?
Zero.
Day 0. Why?
Because you got a penny, the sign bonus.
Yeah.
That was
There's another reason.
yesterday, man. I'm doing.
I know you're right, but there's another reason why.
Wait, Mom, what?
Why am I starting here at 0, 0.01?
Don't you gotta start at 0 on your graph?
That's
Not
sign
necessarily.
bonus. So, like,
That is the signing bonus. There's something else.
He didn't
Zero
work
is
it.
exponent.
0 is not the
I
exponent.
mean, not the exponent, the x or y intercept.
There we go.
Yeah.
I'm starting at that y-intercept because what's a great starting point?
I was saying
The
x,
y-intercept, right?
x.
So once again, I'm starting with a y-intercept. And so we see right here that repeated addition is a what type of function again?
A linear.
A linear function. So what was the pattern here?
Multiplication.
Multiplying by?
2.
Two.
So it's exponent.
Talk more about that. So why is it exponential?
Because you're multiplying by itself each time.
Oh, you're multiplying by the same thing each time. And
Yeah.
what shows repeated multiplication? An
Exponent.
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 Math is not this random bullcrap. It's called exponential because there's an exponent, right?
No.
And what is going to be in that exponent is what we're going to look at in a second. Okay, so is there someone in here who made a table for option 2 but did not put in an equation on the table? Okay, so Jaden,
Yeah.
just because I haven't gotten Jaden at all yet.
Yeah, come on,
Okay.
man.
So let's look at what Jaden did. There he is.
Hey, I only went through 7 too.
Alright, so here's Jaden's. So Jaden, if you can, go to a graph for this, right? We already see the pattern of repeated multiplication.
Go to my graph.
Yeah, go to a graph of that. Okay, go back. No, 1.2. That's what we want, because you already had that one. Hey, really quickly, should we have a line here?
No, because it's curving.
Yeah, it's a curve. That's not a linear function, is it?
No, it's
Alright.
exponent.
Click on that point, or click on that line, and delete it.
Hey, y'all not doing all right?
Leave it here.
Backspace, dude. There's literally a delete option.
Oh, I didn't know.
It's on the top right above the little book, to next to the variable. Wait, why did you?
You want the wrong
No, go
one.
back to 1.2. What are you doing? Let Jaden
No.
click on the line,
I did.
and then hit the delete. There you go.
Good job.
So, here's the thing. We don't want a linear function because it's not linear. So what could Jaden probably do to get the function?
Erase the curve.
Sum square.
Yo, he doesn't want it linear, but could he still get a regression?
Yes.
So what can he do first?
Menu.
Hit menu. Please hit menu, Jaden.
Analyze.
Okay, so let's look at analyze. Not analyzing squares because we don't have a regression. Hey, look at your options. Does anyone see an option that might help?
Go back.
Quadratic.
Hey.
Oh, wait, not quadratic.
Say it again.
So
exponential.
exponential.
Let's look at exponential right there.
Up we go.
Oh, so we got this equation now. Notice, we started with a table. What did we make from that table?
A graph.
A graph. And then, did you have to actually make this equation?
No.
Now we need to know where this equation is coming from, but you can use technology to give you this information.
Amen.
You didn't have to come up with it. Hopefully we are going to get good at that, and you'll have to practice it. But we got the equation y equals 0.01 times 2 raised to the x, or days, right? So, where is that 0.01 coming from, Anaya?
That's your sin. Oh.
That's your
That's your starting point.
Okay, hold on a second. You got a question. What's your question?
But,
Go back to the
two questions.
What's your question? No. I'm saying no to Keith.
Oh, I was looking at the
I'm
graph. I was
busy
trying to figure out where did you see it, but I seen it now.
Where I saw the equation? Oh yeah, it's just right here. Okay, so let's talk about this equation. Where is this 0.01 coming from again?
Your starting
Start.
point.
Starting point, not just any starting point, it's the what?
It's your signing bonus.
Your signing bonus, which is the...
Y intercept.
There we go. Okay, so we want to notice, hey, there's my y-intercept. Okay?
You just told me.
So I'm starting with the y-intercept. Ralston, where's this times 2 coming from?
Slope. Ralston.
Actually, this is a good question. Is this a slope?
No.
No.
Why not?
Because it's not your
It's not
main
linear.
It's not, so it may have been paying attention. It's not linear, so is it going to be a slope?
No.
Nope.
What is it gonna be then? The common difference?
Well, is it a difference though?
No.
Right, so
No.
notice if I take 60,000 and I subtract 0, a difference, it's going to be 60,000. But if I subtract these two, I'm not going to get the same thing every time. Caroline or Braden
What are you
or
asking?
Brianna, do you
What did you
remember?
just ask?
Well, she's asking, what would the name of this rate of change be?
Multiplicative.
Okay, so it is a multiplicative rate of change, but what's the name?
I've never heard that word.
It was a common something.
Common ratio.
I said, what's up?
Common
What's up,
ratio.
boy?
Come get it.
Is it not?
Say it louder.
Common ratio.
It's called a common ratio.
Common
All right.
ratio.
So remember here where a linear function is called a common difference. If you take 0.04 and you do a ratio with the number before it, what's 0.04 divided by 0.02?
0.0.
No. Type it in the
Oh,
calculator.
wait. What's that?
We got technology.
0.01.
2.0.
It's 2.
Oh, it's 2. Hey, what am I repeatedly multiplying by?
2.
Oh, so if I look at that ratio, it's going to give me my multiplicative rate of change. So,
Where'd you come from?
the multiplicative,
Nope. Get these notes down, my boy.
we should still be taking notes under the whole class discussion, but the multiplicative rate of change is called the common ratio.
Yes, I did. 9th grade.
Yep, you did with me.
With me.
The multiplicative rate of change is called a common ratio.
Mr. Kennedy, that's when I was paying attention to you.
I know, it's not like you pay attention now, so.
That's a little bit
You
more
pay,
than I
you pay
was.
attention better, I'll agree with that. Okay, so we've got the multiplicative rate of change called a common ratio.
Yes.
And so you need to know these things. You have to be able to identify the y-intercept. You have to be able to identify that multiplicative rate of change. But once you get those two things, writing the equation is super simple.
Okay.
Yeah.
Okay?
No.
I'm gonna wait a second for people to finish writing. But I'm going to point out one more really important thing.
Yes.
Me.
88.
Okay? So I want to point this out. Eyes up here on this because this is important. M, the slope was 60,000, was multiplied by x because there was repeated addition. So why is this an exponent? Remember, the slope is multiplied by x because there's repeated addition.
Because you're repeatedly multiplying.
Okay, we need to recognize, and it's not just a number that's in the exponent. What's always in the exponent for an exponential? A
Variable.
variable. The variable is in the exponent because there's repeated multiplication. Okay? These equations are not random. They are very intentionally created by the patterns that are happening. That is important to notice. These equations are not random. These functions are not random. They are created by the things that are happening, those patterns, those rates of change. Okay? For both a linear and an exponential function, what do you have to have in order to write those equations?
A slope.
Both?
Oh,
You don't need a slope. You need a y-intercept, your starting point. Now, I will say, you can write the equations without a y-intercept. We're just not going to do that right now. But you need a starting point, a y-intercept, and what else? We talked
A
about-
rate of change.
There we go. You got to have a y-intercept, and you have to have a rate of change. You got to know what those rates of change are and how they're different and how they're similar to be able to write those equations. Okay. Any questions at this point? Nope.
Oh,
What's your question?
I was just kidding.
Okay. Really quickly, I do want to make this note. This is a curve. Specifically, we would call this an exponential curve. That is the shape here, that it is an exponential curve when it flattens out and then exponentially grows like that. All that being said, which option do you think we should go with?
The first one?
Stop.
The first one?
Confirm, yeah.
Okay, so with the first one, Jake, stop. The equation was y equals 60,000x. So how are we going to figure out how much we're making on day 30?
You gotta
Plug in.
So we're going to substitute 30 in,
Multiply by 30.
and I believe we get 1,800,000. Please check me on that.
Shit.
Ooh,
It's a lot of money, isn't it?
a lot of money.
We good with that?
my door. See them pussy came. I got power.
Go see you real quick in the back. I'll get to you in just a second. Okay. So on day 30 with that one, we're going to get 1,800,000.
Yep.
But if I look at the second option, I'm starting out with a penny.
Yep.
How much money do I get? Actually, before you say that, Robert, can you go to your table?
No. You know what? Big pants.
I didn't know that she already had it. If she does, cool, but I want to look at Robert's for a reason. Okay, Robert, table. Okay, scroll, oh, there's day 30. Okay, so notice there's the 1,800,000. And if you look at this table, there's a decimal in there, but what that actually is scientific notation for 10737,418.24. So, tell me again, which one do you want?
That last one.
First.
Option 2. Option 2, my bad, I didn't see it.
I mean, option 2, you get how much money?
$10
$10 million, almost $11 million.
$1 million bucks.
After starting off at a,
$1 million.
and
One
here's the reason
dollar.
why. Listen, what's repeatedly happening in option 2? Repeatedly multiplying. If you look at it again, Robert, can you move your cursor real quick?
Move, boy.
Okay. On day 29, there was about $5 million. Day 28, there's $2.5 million. Day 27, there was 1.3 million. But notice day 26, look at how much less. There's only 671,000 versus 1,560,000. But because it was doubling, it quickly grew. So 2 quick things I want you to notice. Don't look short term. Make sure you fully understand it and make models to see it all the way to the end. When you represent and graph these things, you make tables, it makes your job easier to make an actually sound decision. Pay attention to what's actually happening, okay? How do we feel about linear and exponential so far? Feeling okay? You need to make sure you understand this fundamental information because it will come back in the next lesson very heavily. Make sure you watch the video while you're working on your homework tonight because this homework that is due on Tuesday, it's making you practice write equations from tables and from graphs and identifying the types of functions. Don't forget, I sent you updated directions in an email during second block today, so look at those directions, not at this. You can also go ahead and mark out 21. Don't do that one.
Yay.
Okay?
Yes, sir.
There are
Yes, sir.
updated directions.
How are you going to send us email while we're in school? But you won't even let us know on our phone.
I did it during my planning block. I didn't do it during class.
You know what? It's something about you. George, what?
Okay?
How many fingers?
What's up?
3? What is
It's due. When is it due? What? The big ideas?
Yeah, I'm drinking.
I haven't decided yet. You need to go ahead and start working on it ASAP to fill that stuff out. So we've already covered about 4 of those terms.
I need an orange.
Okay?
This for the exam?
Best friend.
No, that's for this unit. For the exam is the stuff you already turned in.
Boy.
Okay. This green sheet is due on Tuesday. Okay, I'm gonna come collect it in a second. Alright, really quickly. Okay? Really quickly, I do want you to notice, here's another option. This is a linear function as well. How do we know it's linear? This is option 3 on the back of your sheet. How do we know it's linear?
Because you repeatedly added it. You multiply by x.
What's being multiplied by x?
The slope.
What is the slope?
315,000.
315,000, right? So every day that you work for this guy, you're making how much more money? 315,000. And how much money are you starting with as a signing bonus?
2 million.
How much?
0.
2 million, right? That's a great job. I would love to have that job. Put your phone up on, or in the, either on the back counter over there, okay? So, in this job, it's still linear, but if you look at this one, I intentionally, hey, stop and listen. I intentionally designed it so that this would actually make more money than the option 2. However, if you went one more day, option 2 would be better because you would go from that 10 million, right? Almost 11 million to almost 22 million, like that, right? That multiplicative rate of change will eventually catch up. That's what I want you to see. So again, we need to notice our slope, constant additive rate of change, and our y-intercept, our starting point. But here's our next part that we are looking at. This is the gold rush task. This is what the unit is actually about. We need to know about linear and exponential to get ready for gold rush. But this is the gold rush, and this is defining what type of function. What type of function are we looking at now?
Quadratic.
Quadratic, okay? We need to learn what rate of change defines a quadratic. Linear had what rate of change?
Additive.
Not just additive, constant additive. Exponential had what type of rate of change?
Multiplicative.
Not just multiplicative,
Constant.
a constant multiplicative, right? So we need to know what rate of change defines a quadratic function. We also need to know how do quadratic functions appear in tabular, graphical, and algebraic representations. And we also need to begin writing explicit quadratic equations. Now, I need you to pay attention to this context as we start going over it. Because if you don't, you will be partially lost when you start to work on this. So in the 19th century, many prospectors traveled across North America to search for gold. A man named Daniel Jackson owned some land where gold had been found. Quick little side note. If you can, own your house. Own land. Because when you own it and you pay a mortgage, you are pouring money into yourself instead of just giving someone else money when you rent it from them. That is money you'll never get back.
You have someone at the door.
So, own your house and own your land. Which one?
The one about
Which one?
linear, like the job.
Oh yeah. The dream
Yeah,
job.
120.
There you go. Okay, so from here, right?